Hello guys, welcome back to Open Your Minds. It's great to have you back on the channel, guys. This is a new sort of section of my YouTube channel. Every weekend I'm going to be posting informational all-weather video, and it's obviously going to be separate to my weekly City Skylines and Transport Fever episodes and series. But if you like this sort of content, yes, this is where hopefully you would enjoy a bit of this content. Right, we're sat over central, southern, and obviously parts of northern Europe, but we're just sat over Europe in general. I didn't know why I had to do that. But it's the 26th of July, 9 a.m. BST. And what I'm going to sort of do is we're having a really bad heat wave in central southern areas of Europe and in the parts of the east of Europe. And I'm going to take you and sort of show you how it's happened and how it's developed, and a sort of hopefully a tiny bit of the meteorology of it. That's what we're going to do, and we're also going to, it's the 31st of July, but it's going to be the 32nd of July when I post this video, and well, actually it's going to be the 1st of August, so that's a perfect time. When I post this video, it'll be the 1st of August, and the second part of the video is basically just going to be me going through the temperatures all over Europe and certain areas, regions in Europe and all the different countries, and tell you how are they above average, are they below average, and I'm also going to do that with precipitation. So we're going to have an outlook, and we're going to, have an outlook of July. So here we are over, I'm so sorry, excuse me about that. Oh, quick disclaimer. I'm so sorry, I'm not the best at pronouncing stuff, so I'm so sorry if you're from other countries. I'm from England personally, and I pronounced your city horribly wrong. I'm so sorry about that. But I'll try and do my, I mean, I'm really not very good at it. But okay, so we're starting. We can see this is actually a below average day, or especially for this July, which has been extremely hot, because the omega block and the heat dome has broken since it's been over Europe for such a huge amount of time this summer. This is actually, for this summer particularly, this is a very sort of off-trend day. This is a sort of below average, really below average day for especially England, France, and parts of South Spain and Portugal, which are directly facing to the coast, the sort of western side, but all of them really in general. So we're sort of starting the day. It's very cold, you know, or cold for this time of year. I mean, much below average. Paris, 18 degrees. Obviously, we have hotter temperatures coming through, and then obviously these areas where Paris is either cloud or rain bands. And we're going to pop through, and we see this. There's obviously hot areas. There's still loads of areas which are still kind of above sort of average, but it sort of goes straight through Europe, and it really cools Europe down. It's probably a welcome break for many people who've been dealing with this extreme heat. And obviously we're behind time now, but I'm taking you through. And so as we come up to the fourth heat wave fourth heat wave of the year so far for England and the UK. I'm not sure what it's for other countries. I should probably search that up and probably put it somewhere in writing somewhere, hopefully, on the screen. So as we speed over to the 27th, we can see, I'll just quickly show you. We can see, I'll show you where the jet stream is. This is the jet stream here. It's sort of coming on, it's sort of really southerly pattern. It's coming straight down. It's kind of, it's not really going northeasterly. So it's kind of coming straight through Ireland and through southern England and maybe the northern bits through northern England, then through Germany, through France, and it's done that pretty much all today. That's why it was so cold, because it's a properly southern jet stream. This is a sort of jet stream you might get in winter, or sort of in autumn or spring. It's not really a summer jet stream. I think even in normal years, this would be sort of when the jet stream comes down, we get a colder spell. But as we come into the 27th of July, we can start to see the jet stream is starting to sort of level off. It's not starting to come down as far. It's starting to sort of go more easterly instead of southeasterly. And we can see slowly through the day, it's going to start warming a bit more. It's now the sort of south part of the jet stream is more going through northern England by Cumbria and Newcastle and sort of Durham and Northumberland. And we can see, sorry, too far out. And we can see through the day, it just keeps going up, and it kind of snaps quite far up north. This is a classic heat dome, and sort of it starts going back to to what we've had this summer, the classic up and around jet stream we've had because of this omega block, and it just snaps back to that classic jet stream we've had all summer, and it just snaps back to that classic up and around. And then, yeah, we can see suddenly it starts to go straight. Now it's more, instead of east, it's more northeasterly, going straight. It's kind of going straight over the Scotland. It's kind of, you can see this right south of it's going over the south of Scotland. No, sorry, the north of Scotland by Stoneway. And also, I mean, the wind is sort of pushing it through the North Sea, and it's kind of hitting Norway quite hard because the jet stream can't push far up north, but it will be able to hopefully soon, because it hasn't come back down south. And it will usually, most of the summer, the jet stream's usually done an up and around pattern because of the omega block. It's usually come from obviously the sort of Gulf of Mexico, and come all the way up. And instead of a winter pattern or a spring pattern where it goes down to Spain or comes through England, which is kind of the normal spring and autumn pattern where it goes through England, goes through a central northern Europe, and then sort of sometimes in winter it can go through Spain and southern France. But instead it goes the proper omega block because there's a high pressure here in the middle of Europe. It's mostly this summer it's been over France. And the jet stream just is a proper over and around. It goes straight through, sometimes even through northern Iceland, and sometimes here in the southeast of Iceland we've had some quite hot temperatures. The hottest I remember was 25 degrees. And it goes straight over, and then it goes straight, slams into the north of Norway by Tromsø, Trondheim, also I believe somewhere around here. No, it's actually further down south, sorry about that. Tromsø, or between Tromsø and Bodø, and then it goes straight through also by Finland, and it comes straight back down, hit Murmansk, and it comes straight back down and gives quite wet. It sort of comes straight around, and like sort of, this is the sort of pattern, so you can see from a wider perspective. It comes up and then it goes straight down as soon, because over Eastern Europe there's more low pressure, and because high pressure is over the west of Europe, it just comes straight down. And really, this you'll see later on in the video, there's been a real split in between Europe. The west of Europe has been very hotter than average, drier than average, and the west of Europe has been wetter and colder than average. You know, even like a massive example is this. Usually Berlin is colder than London, by a couple of degrees, but actually this summer I think London's actually averaged a higher temperature than Berlin. It's consistently averaged a couple of degrees higher, and that's just the proper splits we've seen through this summer. And Berlin's kind of in the middle of it. Sometimes heat comes there, and all the way down south to, I mean, it's not been so much the late half of the summer, but especially the early half of the summer. Some parts of central Turkey have had a really cold summer. So as we see that, it's not moved straight north there, but it's moved, the jet stream's moved far enough north that it just goes straight through the south of Norway and then into the Baltic states through Sweden. But it's moved further north that it allows high pressure to basically escape from northern Africa and go into the Iberian Peninsula. So you can see this day. This day you can see this. This is a classic waiting for heat waves. You can see here it's not that hot. And then suddenly from 3 a.m. there's a suddenly heat spike, and you see 41. Like it's a classic sort of signal. There could be there's either heat over the Iberian Peninsula heat dome, and we just need the southerly wind to bring it up to northern Europe. And it's just waiting in the wings, or we're kind of straight in, because now we're kind of seeing we're having a pattern straight from sort of jet stream to because you see now the jet streams move further up north. That we have, if we go to pressure, it's the perfect setup really. We go to pressure, we have low pressure up north in Scotland. To be honest, people don't realise actually the UK sometimes in the summer has quite a crazy microclimate between the north and south compared to its compared to basically its size, and it kind of outranks quite a lot of countries. But we're going to do a whole different video on that, because I think that's going to be a great video. But we see we've got low pressure to the north, low pressure to the west, low pressure to the east, and that's the perfect setup to create a southerly wind. you can see here the straight southerly wind through France. I mean, it's not completely straight, but you can see it's going in a southerly direction. Sometimes, you know, wind goes different directions, but it shifts a lot, especially in English Channel. But it's just taking that heat up north. You know, sometimes, you know, winds change all the time. You can see they constantly. So, but it's a sort of a average trend where winds will travel up north, and see it's constantly here going through the south, and that just drags up the heat dome, drags up heat to countries like France. So we see and then we see that this is this was the second hottest day for countries like the south of the UK and France of the heat wave, and we see. Then this is the first hottest day. We see the heat dome and high pressure actually start to move northeast. So we see there is but we still the high pressure is quite big, because you can see this is where the sort of main part of the high. So this is sort of the high pressure is now over France. It's sort of over here. It's got maybe a bit of southeast of England, but it's mainly over Brussels, France, and this part of southern southwestern France, because you can see it actually really gets blistering. I can't say it. Blistering hot, if you know what I mean. Hopefully you know what I mean. But it gets really, really hot here, because obviously now wind is like colder temperatures are moving in from the Atlantic, swishing this really hot air, and that can sometimes create 44 late in the day. I think it does there. 44 degrees. That's really hot. That's starting to get close to the average. Oh, sorry. There we go. There's 44 degrees. There's your 44 degrees. We don't need to press that. But as we see, this is the hottest day for parts of the south. We can see some of the Crawley this is the hottest day for them, 35. I think it was once in London, or maybe that was just me, but you can see it's a lot hot and up, and obviously the heat is now leaving. You can see where, because obviously we've got a lot of southerly, and also you can see where the southerly is where the heat leaves the continent. So you can see here is constantly leaving in the south. And constantly is sort of a northeast. You can see where the heat dome is moving, also by where the wind is. See, it's coming up through, because the heat dome is moving northeast, but it will eventually move southeast later. You can see the wind is going through from like Southampton to Norwich and then out to sea. But yes, we want to carry on, because this is going to be a very long video for you constantly. But yeah, this is the hottest day for parts of South France. Paris, this is the hottest day. Parts of Southwest France. That was really bad for the Bordeaux fires, but I'm going to do a separate video on that. And it was really bad, basically. It was the hottest day for most of France. And I think it was the same hot days for Spain. And then it was the hottest day for Netherlands, parts of none of Germany. Luxembourg. It was the hottest day for the south of the UK, France, Belgium, Netherlands, and Luxembourg, I think. And then we can see the heat dome starts to move southeast, or more. It moves more east, but it starts to move more southerly. So we can see now heat setting up in Germany, and it's going to start to pull, start to come down to some more southerly. We can see here, especially gets hot here, and as we have this low pressure. We have, obviously, because it's that's humidity, sorry, we can see there's just this because now the heat dome's moved let's get pressure. So now the heat dome's mainly over here. We've had high pressure here, but we can see that the jet stream is starting to come back down again, but starting to create a bit of disruption here. But we can see this is where the heat dome is now moved from the west of Europe to the east. This is where and then it sticks here for a long time. I will show you that in a minute. But over the sort of east of Europe and the central bit of Europe. So here we go. We have it's a relatively hot day in Germany, but sort of the same temperatures we had in France. So 38 in Cologne, 37 in Stuttgart, nearly 40 there. I think it did. Yeah, as obviously we've got this cold air squishing. We have this colder air squishing, and then we have a lot hotter air, and then we're gonna come on to March, and we can see from the 30th. Now it's moved. Now the pressure, we'll show you in the night, is moved more southerly. So we can see this is where Milan is now in. Italy is more where the high pressure is, and now the heat is on for Croatia, Hungary, Bulgaria. Serbia. parts of Bosnia-Herzegovina, and some parts of Austria. But we can see now, we can 28 degrees, and now this is going to be some serious heat. We've the heat dome has been in place. The longer heat dome is over somewhere, the hotter it gets. So as the heat dome's been slowly moving over Europe, the hotter it gets. I mean, if it was just stuck constantly over one place like it was in June, where we had high humidity, high heat over southwest France and parts of England, parts of Spain, it gets a lot hotter, a lot faster, but it's still gaining a couple of degrees, a couple of 0 point degrees as it moves over to the sort of southeast of France. And so we can see in the valleys here, because obviously this is actually quite a high altitude area of Europe, and we can see in the valleys and where obviously parts of Hungary, parts of Serbia, and parts of Slovakia and Austria and Czechia, but mainly, and also Italy, are really heat magnets, and that's basically down to geographical location, and how their land lies, and how basically they can retain heat quite well, and it can really get quite hot in these areas, mainly down to geographical, basically location. As we go through the day, we can see they both have really, really hot days. 38 degrees, 40 degrees in Milan, and because we have the urban heating sort of phenomenon. Obviously, in hot cities big cities like Milan, where we have heat coming in, which is very, very punishing in the day, 40 degrees. Obviously, in cities like Milan, there's a lot of concrete. There's a lot of concrete and sort of just other big stones they use for pavements retains heat. So therefore, you'll find in summer places like London, Milan, and Rome just find it very hard to lose heat through the night. And in Europe, we have a lot less air conditioning as say you have in America. So therefore, say the high percentage, then you would think people in Milan don't have air conditioning, so therefore it's more dangerous for your health if you're in a city, because the temperature there's not so say in rural areas, say tonight, let's look, say we go through today, it's like it might even hit 41. Gee, it's so punishing, absolutely punishing that day. Wait, did I just go through the day? I might have just accidentally. No, I didn't actually. It's fine. We're moving to the main day. This is today. We're just as we basically move, we have. I don't know what. So it's even just today. So say it's 39 degrees, and see it's coming into nighttime. We obviously got cold air coming down from the Alps, but see Milan still finds it hard to lose heat. So at 10 o'clock, 10 o'clock BST, and obviously I believe Milan's 1 minus. I think it sometimes tells me here. Milan, no, it doesn't. Oh no, it says 2 minus, UTC 2 minus. So actually, it's at midnight. I actually thought Milan was 1 minus. What an absolute dingleberry I am. What an absolute shit. I'm not going to say that. You know what I do on this YouTube channel. If you're a normal subscriber, I sometimes say that bad word, but we're good. So it's midnight here, and it's still 30 degrees in Milan and the urban area around. And you can see this retains a huge amount of heat compared to a lot of stuff. And also Turin, it's another big city, but it still retains a lot more heat than the surroundings. Around Turin it's 28, 26 here, it's 22, and this is what the 26. This is what the urban heat, sort of. I forget what the last name is. Urban. I'm going to just quickly search it up. No, it's fine. We're not doing it, but it's called the urban heat something. I forgot the last name, but it's called the urban heat. It's basically, I've explained it to you, but this is what it does. Because you've had such a hot, punishing day, you need nights to recover. So therefore, if you're in an urban area, and obviously because the urban heat effect, and that's what it's called, the urban heat effect, it doesn't cool down as much as rural areas, it's harder for you to basically replace and basically recover through the night. This is why it's so punishing sometimes in these urban areas. And we see here it's 30 degrees, and it just does not cool down at all. And obviously because Milan probably has one of the hottest daytime temperatures, obviously because there's more urban and traffic and more pollution and just more urban heating, because there's loads of buildings that retains heat, so it probably has one of the highest highs. So we go to I know we're just focusing on Milan, I'll focus on we'll go wide in a second, but we can see this is one of the most punching days, 41 degrees. And obviously, we need to focus on what that actually feels like for people living in Milan. 40 degrees, and in the surroundings, 41 degrees. Let me tell you, if you do not live in Europe or in this area, I think 32, 33 is about the average for Milan. I will put it up in some area of the screen because I can't remember, but the average temperature will be somewhere here, and this will be a comparison. 41. It's just that's actual temperature, 41 degrees. But just the feels like temperature is the most important for people's health because 41 degrees feels deadly, and this could also obviously have affected the economy and the local economy of northern Italy because 41 degrees, there won't be any people working out on the streets, maybe in offices, but manual labour will be completely. There won't be anything for for the whole working day, and this could have maybe a tiny effect on the sort of northern Italy economy. And obviously, this could have a huge effect on the agriculture. But sometimes northern Italy is saved. But that's another danger I'll tell you in a minute. But we'll just quickly speed through northern Italy's temperatures for tomorrow too, because this I think we actually got 2 days. It goes out to the 33 because it's the 31st today. But since you're watching this, since this video is going to be published on the 1st of August, this is probably what you most like it because this is what it's going to be. Just pick a time when you're watching. It only goes out 2 days, so it'll only be to the 2nd of August. But we can see it's still really. So let's see how hot it's going to do. Let's predict quickly, just as a fun game. So it was 29. What was it on the 33? So actually, today's probably going to be a slightly cooler day because there's air, which there was a bit more air which came down from the Alps because I believe there was storms forecast for. I might show you that because that's another massive risk. That's another thing I really want to quickly touch on in a second, but it's not as a hot day. Well, maybe it is. It's still 37. Well, actually, it's 2 a.m., 2 p.m., so it's not going to be as hot. But no, 39 is still really hot. In other areas, 40 degrees. It's still punishingly hot. And it's just the urban heat effects just doesn't allow people to recover. And this heat wave is forecast to be a long time. The last time I looked at it, a couple of days, maybe a week or maybe a week and a bit. We're look at about in seconds. But this is really dangerous, like super high temperatures, and because obviously the urban heat effect, people can't really cool down. You see, at 11 p.m. it's still really hot. Sorry, I have to play with the time because this is just have to 2 minus everything, and then obviously it's 5 a.m. We're now 26. Still 26. We can't lose that much. This is the key time where we need to lose heat. This is probably the best recovery time. And then we're still 26. How does that balance out to? This might be a hot day because I'm going to predict this is going to be 41 highs. It's quite a fun game because something might change later in the day between. I think this is going to be quite a 40-degree high, maybe. Nah, I'm wrong. Never mind. Okay, 39-degree high, but that's still really, really high. See, 40s around. It might be if we have any humidity, no, but it's still punishingly hot. It's compared to its average temperature. I think we're still hovering. We'll look at that, and I'll put that what all the days we've just looked at how above temperature this area was, and we'll just put that somewhere on the screen now. Okay. Just give you a tiny bit of time to think about that and look at that because I think it's going to be quite. But the next area I want to look at is obviously this is the other area, which is because geographically in these areas, these are the 2 hardest hits because the pressure. Obviously, that's the humidity. I keep pressuring on that by accident. The pressure is here. If we go from midday, we can see they have a lot of pressure at midday. This is where they get most of the heating. And you can see the pressure, especially around Budapest, is quite high. And this is where the geographical location allows them to heat up a lot. And we can see, especially most of Hungary, a lot of northern Serbia and parts of eastern Croatia can be bad hit. Some of the lower lying areas, lower latitude areas of Bosnia and Herzegovina. The Sarajevo, the capital of Bosnia and Herzegovina, is really obviously quite well kept, especially in the heat scenarios, because it's quite high up in the mountains. Obviously, it keeps it quite cool compared to other cities in the region. So we're looking here, and we'll just do. Hungary, Budapest doesn't get as hot. Belgrade doesn't get as hot, but I'll quickly pop out the average temperatures for Zagreb, Belgrade, and Budapest, and we'll just quickly look at I'll just put that up there, and then I'll just quickly squeeze through the times, and obviously because these areas, Budapest, Zagreb, Belgrade, all have not as much as Milan, I don't think. I think, no, actually Budapest might have a bit more. I'm not sure which is a bigger city, Milan or Budapest. I'll also put that up somewhere in the screen in a couple of minutes. But whilst you're just looking at those couple of information, I'll just quickly be silent for a second. I'll just you'll look at the temperatures while looking at also that information on the screen, and then I'll just quickly go to a couple of risks, especially for the northern Italy, and then we'll move on to something in a minute, something else. So I'll just quickly do this. I'll shut up for 2 seconds. So this is the 31st. I'll just quickly call out the dates. So we'll go back to the 9th. 31st of July. Okay, we 1st of August. 41 degrees high in central Hungary. 42 degrees high in central Hungary seems to be the pinnacle of the heat, and that's as far as it goes. But one of the main, you can see here, so especially this day, this could be some extreme, because the hotter, because obviously northern Italy has, I mean, you might know it if you're watching weather content like this, northern Italy has a very reputation for being a huge storm magnet. Obviously it's quite simple because we have colder air up in Alps, and later in the day as cold obviously as low pressure systems form. Because we have cold air in the Alps, and as that later in the day, as that sweeps slightly further down into the sort of valleys of France and other areas, and obviously Spain. No, not Spain. Sorry, Italy. So as the cold air from the Alps later in the day, so like 3-4, goes down, all the hot air spike, because that's the pin. It's usually actually sometimes, especially in this sort of scenario, it's hot air which creeps up, and or can be the cold air which creeps down. And when obviously cold air creeps down or hot air creeps, they clash, and that can create some very dangerous convective thunderstorms. Very dangerous convective thunderstorms. It's mainly in this scenario heat going up into the Alps and clashing with the cold air, and that can create some heavy cumulonimbus clouds. I'll put that up here too, because I can't pronounce it properly, because I'm just not very good at pronouncing stuff, so you know what I'm talking about. Hopefully you know what I'm talking about. Hopefully I pronounced it well enough that you have a relatively good idea what I was talking about. But you have huge cumulonimbus clouds coming down when the cold air hits the hot air. Huge cumulonimbus clouds coming down, and as they hit the hot air, they gain convective energy, and therefore these can be some of the strongest thunderstorms you see in Europe. I don't actually have any videos of live lightning radar, but I've seen a couple of some 300 millimeter of rain, some of the hardest rains I've ever seen as I've been studying, or not studying, just analysing and sort of looking at weather for a long time, and it has some of the highest density of lightning storms, and lightning strikes, and it has the one I saw the other day was 300. I think it pinnacled around 392 lightning strikes per minute. I mean that's was that per? Yeah, it's per minute, and that's a extremely high amount. I mean, this year, this summer has been quite crazy for thunderstorms. We've had a very one of the biggest ones I've seen in the UK, 166 per minute, and that's quite a bad storm for the UK. But that's very dangerous, because the hotter it is, and because the hotter it is, when it comes down into the valley later in the day, it will be peak temperature. So that means it will get the peak convective. So basically, if it was coming down in the valley, it was 32. That will be the normal convective energy. And anyway, those storms are still super powerful. But with that extra sort of 38, 39, that's a huge amount more convective energy being pumped into these cumulonimbus clouds. Therefore, this makes them extremely powerful. And we can see here, this is a sort of, sometimes when you have low pressure pockets, sometimes squeeze and see we have here. I think there was also, if we just go to precipitation outlook and we go to the 31st, we go to here, we see here, we see these later in the day, these start forming up in Alps, and this can sometimes form into quite heavy. Sometimes I think they might be underestimating how heavy and dangerous they'll get, but I think the one, there we go, that they can sometimes be quite bad. Yeah, see, it just needs to be in the right place. See, that could be very dangerous, but I'd be predicting they'll be quite bad. But I think probably the most dangerous part of this will be when the heat wave ends. The thundery breakdown of this is because northern Italy is in a perfect position to have some of the worst thundery breakdowns after a massive historical, and probably, in my opinion, probably the most dangerous heat wave so far this summer in Europe. And the thundery breakdown in northern Italy could be extremely dangerous. And I mean, if it's long enough, a week and 2 weeks, maybe some vegetation that could be dry up, and it could create some. The lightning could start a wildfire. But I think it gets quite a lot of lightning. I mean, obviously, we will see how the wildfire season sort of after this. This is definitely going to be, after this heat wave, this is going to be opening the doors to maybe, hopefully not. I'll pray. Definitely, we have to pray not as punishing and devastating as the Western European wildfire season, but it could definitely open the doors to something like that. I would not be surprised if there's something powerful as that, or a little bit less powerful. Okay, so what we'll do now is we're going to quickly look at basically some weather model outlooks of what's going to happen over the next couple of days. We're going to look at ECWF and GFS. Those are two ones I not like looking at, and obviously can't look at all of them. It's going to take ages. So I'm going to see you on the other side of the edit. Goodbye. Don't worry, guys. See you on the other side of the edit. Goodbye. Hello, guys. Welcome back. Right. Wrong one. I just realised. No, we're not wanting that. We're wanting this one. Yes, this one. I like to use. Righty ho. ECWF, we go for this one. But okay, so this is ECWF, the first one I like looking at. It stands for I think it stands for European Centre of Mid-Range Weather Forecasting. I'm pretty sure that's what it stands for. I'm 100% sure, actually. Okay, so this is actually, we really don't need to look at the next couple of days. I've seen that's the second, that's the third. Okay, here, fourth. We can start, looking at paying attention. So here, it's still pretty hot. Let's see what ECWF predicts. So 37 at midday, especially in that heat, especially that area which gains the most heat. We've already seen it in Zoom Earth radar, which has a bit of a trend of sort of retaining and sort of definitely punishing heat in that area. It seems to be sort of a heat microclimate pocket. As 40 to 39, and it seems to be highs of 40. So yes, I mean, ECWF, I think, in my opinion, sometimes underpredicts stuff. I'm a personal bigger fan of GFS. The global forecasting system with the United States of America, the USA. So yeah, I mean, it's 37, 38. It seems to be 40. This seems to be a hotter day. It seems to be 38 in Milan. I think Milan's about there. 38 Turin's about there. But then it seems to be highs in that heat area about 4. It's definitely sort of that microclimate pocket we sort of picked out. 6, we go to this is the 6th of August. Sorry, I should have called out one thing I really, they don't have 9 o'clock, which is slightly annoying from now on. But okay, 41. This seems to be a hotter day. This seems to be maybe we're really starting to build on heat. I don't know why. So, maybe the high pressure heat dome is built even further, locked in even more. So the heat dome is locked in even more. The heat wave is locked in even more. So therefore, temperatures just keep on climbing. Obviously, temperatures will climb to the maximum temperature that if a heat dome sits. So say a heat dome sits over central France, just for a little example, so there's constant high pressure, the ground's constantly baking. That's the temperature. If that basically say the heat dome is there for a long time and nothing moves it, not the jet stream or not some low pressure system from the Atlantic, the temperatures there will keep on climbing to the maximum limit of the atmosphere over that Pacific region of Europe. So therefore, if a massive heat dome is over the whole of Europe, different areas will have different maximum temperatures. But from the atmosphere, regional atmosphere. So say in Cardiff, the hottest temperature might be 43, but in Budapest it might be 47, or in Paris it might be 45. Stuff like that. It's just a bit of example. It's from hopefully my good understanding of that. Hopefully it's good understanding. But so yeah, we see it's 40 degrees. So it's definitely a hotter day, the 6th of August. We see it's 41 degrees. Yeah, so as we move into the 6th or the 12th of August, yeah, 30, 40, 6th of August. So I mean, we really do. So these seem to be a holiday. 9th of August will just spring through quite fast now, because 41, because I mainly like looking at GFS. 12, these seems to be holidays, but this seems the 10th of August might look like a breakdown. If we go back to the 10th of August quickly. No, where's it? Oh, wait, okay. Oh, it's the 9th of August, silly me. Yes, it definitely looks like a breakdown in central, northern Italy. It looks like a breakdown in northern Italy. Could it be the 8th or so? Yeah, oh wait, no, that's the, no, I think it's the breakdown in central Italy is the 9th of August. Sorry, I got a bit there's just quite a lot of greens here. I accidentally pressed them wrong out. But I would definitely put out a bad warning for the afternoon of the 9th of August. I would not be surprised if there's some severe thundery breakdown there. So if you're from northern Italy or on holiday there, please, I'm not 100% sure, but I'm 98% sure that would be quite a danger area for convective activity. And it could be very extreme. 6 a.m. So this, but it still looks like the heat wave is slightly hanging on. No, see here, the 10th of August is the breakdown in Hungary and Serbia. Excuse me, and that's Eastern Europe, sort of more the west of Eastern Europe, but it's still Eastern Europe. So I mean, we really don't need to look on it anymore. But the one I like looking at more is GFS. Because I mean, really, GFS. I have a temperature reading. I have a specific temperature thing which reads a temperature at my house, and all the heat waves we've had in the southeast of the UK or the south of the UK, and what GFS was predicted, the temperatures I actually recorded on that day has been closer to GFS's predictions, even though they sometimes waver like all weather models do. It's been closer, so that's why I personally, I personally like GFS more, the global forecasting system more. But you might not. But I think this will be the most accurate. So we see here, so we're going to zoom out because we've already seen this actually. What we're looking at with Zoom Earth radar is that was actually GFS. It will be like the exact same. So was it the 3rd of August we did the stop? Yeah, it was, because, yes, okay. So we go to 9 a.m. So it's going to be 39 or 42. That's just, it keeps on getting hot in that microclimate we've seen, because on the 2nd of August we had a high of 42 there. So it's just going to keep on getting hotter, and with the heat wave also, that extreme heat from that microclimate is just going to expand out. And it's just going to keep on exacerbating, getting worse, like 42 here. This seems to also be a problem now, but I think as the heat dome has moved slightly more east, that sort of Milan area has been slightly less badly hit, but it's still in the high 30s, which is definitely a heat wave threshold, I believe, for that area. So it might move back west, we'll see. But you see 42, these are the main problem areas around, I believe Belonga's here. Bologna is definitely a city which you need to watch out for in that region. The sort of north east sort of Italy is definitely a problem area, and obviously up in northern Serbia and parts of Croatia, parts of Bosnia and Herzegovina, and most of Hungary. You can't see the top of Hungary, but it's kind of the same. This is probably the best one I can get, which captures all the countries mainly, because all the other ones don't really capture all the countries, because Eastern Europe doesn't capture Italy, or does it? No, it doesn't. Yes. Yeah. So on from that kind of distraction, but we go on to the 9th, and we can see that 40. This is probably going to be the hottest day. I mean, I would really put out that's some extreme heat. That's like, if that actually occurred, that would be a red health warning, I would have thought. 44 degrees. That area, I'm going to quickly find out. I'm going to quickly put here the average temperature for that area around here. I'll do this behind the scenes, find out the average temperature. 44. How does that compare to the average temperature? I'll just quickly put that in red over there. We'll carry on. So 44, and that's not even at midday, or actually that is at midday, because we're looking here 12 minus. That's actually 2 o'clock. So this might be hotter. I mean, I'm not sure. It still retains heat, because now that's like 5 a.m. in the evening over there. I have to keep on like minusing 2 from everything. But that's later in the evening. That's like more like 8. But it still retains heat so well. I feel like the thing that GFS does slightly wrong. I feel like it won't retain that much heat, because it is about to literally be dark there. So I feel like that's slightly what GFS slightly lacks on. That might just be me. But so we're gonna probably speed through this, because we want to get on with the video. So 44, it's very hot there. You know, this is most of the extreme days. I would say the 5th is going to be another very, very hot day, the same, and it just gets worse. See, just the heat dome just expands, and then it's the exact same thing that microclimate with their first 44 was on the 4th of August. It just expands to even more. The heat wave, it just expands east, and it's 44, and even in that area it's 45. And we'll look at the average. I'll just quickly put the average temperatures for that region there, just to see for like different locations. Hopefully it's still there, and then I'll take it away. But we're just going to quickly look through, because I want to get on to other stuff now. So yeah, this is probably the hottest days of 3 days we're looking at. Just quickly go back to this day. How hot is it? These are the hottest days. It's also the 40s have also made it to Milan. It's going to be 41 there for probably 4 days this heat wave, which is extremely dangerous. And I wouldn't be surprised also there if there's a red health heat warning, or amber health heat warning would be definitely, if this would definitely if I was the government, definitely something which would need to be done to warn the public about this extreme heat wave which is occurring, which could definitely, for elderly people, this is a real massive danger, because they're just not used to this heat, and this could seriously, I'm not trying to be rude here, but 45 could, to some people, could easily be deadly, and I think for most people, I think this is sort of a red sort of heat health warning, because it's not just elderly, young babies, young children, and elderly people who are vulnerable. It's a whole population at this rate. When it's 45, high 40s, and also even if it's 45 degrees, even if it was for high 40s or 45 degrees, for a Pacific. A 1 day in France, that might be doable. That might, that could be extremely dangerous. But this is like 3 days, 5 days where it's in the 40s. I mean, this has to be a red health warning, because this is ridiculously dangerous. This is why this is definitely going to be, if this occurs, and some low pressure, wild, random, or just say this has happened, which is pretty likely. I'd say 90%, probably more like 98% this occurs. I mean, we're still quite far out, but I would be very surprised if there's a low pressure or the jet stream snaps back south. So if this occurs, which is pretty likely, this could be the most dangerous heat wave we've seen this season so far in Europe in the summer, and it's been a pretty crazy hot season. So, and it's definitely then leave Hungary, parts of Serbia extremely dry and like completely vulnerable to wildfires. But it just gets worse. I mean, it just, again, 7th of August is like a really bad day. It's just constant, extreme heat, and it just seems never ending. At this point, I'd be wanting out. If I had some money, I'd be like flying out. But yeah, it seems to break down in the north of Italy. So maybe it's still hot. I wouldn't be thinking of a full thundery breakdown, but maybe a couple of thundery convective activity that day, because it is sort of 12 a.m. Maybe no, but it still gets hot there. So I wouldn't be saying full convective, but it's definitely looking like it's slightly breaking down, and the heat dome is slightly moving further south, because you can start to see the microclimate pocket starting to come up in Greece, around Thessaloniki, around North Macedonia, Albania, and and also down in Sicily, and parts of Naples, and parts of Bari. I thought it was here, B-A-R, is over there somewhere. I'll put that up there. Just Bari, I think that's how you say it. Barra, I'm not sure, but that, and obviously down, and it's going to be very hot, and obviously now it's going to sort of going to Izmir, or down here, is it Izmir? I went there once on holiday, but it's somewhere around there, but that's also going to be getting hotter. I'll also put that up there so you know what I'm saying, and I'll also probably label it here somewhere, but we'll just quickly speed over the last couple of days, because I really don't want this to go too long. Okay, so we'll just quickly, so that's the 9th of August. I think we'll probably have a full thundery breakdown in northern Italy that day. And then we can see the heat dome moves further east even still. And this area is probably parts of southern Hungary and sort of Serbia is going to be hit even further with the sort of heat still moving. And I think as we get later in the evening, later in the week, it's going to start. Yeah, there's the full, it moves further south and moves into Romania and Bulgaria, and then it just is. And I think it only is there for a couple of days, and then it might move out. Or are they going to get a small heat wave? No. Yeah, and then it moves further south then. Okay, we're going to go on to the second part of the YouTube video, and then we'll just tell you, it's probably going to be a massive Excel chart, and then just it's probably going to be just me reading out and then just telling you just an overall analysation of what July's been, how I personally thought about it. But I'll see you on the other side, guys. Goodbye! Hope you enjoyed the first part. Woohoo! Hello everybody, welcome back to the second half of the video. This is going to be the second part of the video. It is basically going to be a July outlook and sort of analysis of all of Europe. I didn't do Eurasia because, it's already 125 cities. If I did Eurasia, I would have probably quitted this video. So I'm going to be doing this. I'm just basically going to be reading through everyone, and then at the end of it, we'll go to a map of Europe and I'll do an analysation of stuff. So this is literally just, you can skip maybe if you want to your Pacific city or where you live, and you'll have to just skip through, see where that is. But just quickly saying, positive, green equals positive temperature, so above average, and red equals below average. And we're doing London, and then we have the temperature and this and the precipitation outlook, or basically the whole month combined. And this basically London 3.44 degrees above average and 45 millimeters below average is compared to the historical average. And that is compared to the historical average to this year, to this month. Historical average this month. Sorry, that's pretty obvious, this month. So this is basically compared to the historical average, compared to the historical average. Sorry, I repeated myself a tiny bit there, but as you get it now, we'll just put on a bit of a nice relaxing music, and I'll slowly go through them. Obviously, I'm reminded I'm not very good at pronouncing, so please don't get offended. Please don't get too offended if I mispronounce your city or town name in this list. Okay, so here we go. London, 3.4 degrees above average, 45 millimeters below average precipitation. Southampton, 2.5 degrees above average, 35.2 millimeters below average precipitation. Cardiff, 3 degrees above average, 71 millimeters below average precipitation. Norwich, 3.1 degrees above average, 56.7 millimeters precipitation below average. Birmingham, 2.9 degrees above average, temperature, 6.13 millimeters above average precipitation. Manchester, 2.4 degrees above average. 54 millimeters precipitation below average. York, 2.7 degrees above average. 62.2 millimeters of precipitation below average. Newcastle, 2.1 millimeters above average. 2.1 degrees above average. Sorry about that. 43.5 millimeters below average precipitation. Dumfries, 1.8 degrees above average. 39.1 millimeters below average precipitation. Edinburgh, the capital of Scotland, 1.2 degrees above average. 19 millimeters or below average. Aberdeen, 0.8 degrees above average. 30 millimeters of precipitation below average. Inverness, 1.1 degrees above average. 26 millimeters precipitation below average. Lerwick on the Shetland Islands, 0.3 degrees above average. 37 millimeters below average precipitation. Londonderry, this is now Northern Ireland, 1.4 degrees above average. 14.5 millimeters below average precipitation. Belfast, 1.7 degrees above average, minus 68 millimeters below average precipitation. Cork, now this is the Republic of Ireland, a different country, 2.1 degrees above average, 63.4 millimeters of precipitation below average. Dublin, 2 degrees above average, 49.8 millimeters below average. Now this is France. Lille, 4.1 degrees above average, 29 millimeters below average. Nantes, 4.3 degrees above average, 38.5 millimeters below average precipitation. Lamaze, I don't know how to say it, but 4 degrees above average, 26.4 millimeters below average. Paris, 4.5 degrees above average, 57 millimeters of precipitation below average. Nancy, 4.4 degrees above average, 65.3 millimeters below average precipitation. Bordeaux, where the wildfires have been, 4.9 degrees above average. Sorry, that was the error there. 44 millimeters below average precipitation. Lyon, 3.6 degrees above average, 23.7 millimeters of precipitation below average. Nice, 2.8 degrees above average. 12.4 millimeters below average precipitation. Toulouse, 4.4 degrees above average, 32.9 millimeters below average precipitation. Sorry, this is going to be long, isn't it? Now on to Belgium. Brussels, the capital of Belgium, 2.2 degrees above average, 66.3 millimeters below average precipitation. Liga, 2.2 degrees above average, 65.8 millimeters below average. Oh, by the way, if you're from a different country, all the names in this list are how you pronounce them in the UK. I didn't have enough room to do how you pronounce them in the original country or the country of origin that city belongs. So on with the show, on with the journey to the bottom of this Excel page. Amsterdam, 1.5 degrees above average, 61 millimeters. Oh, this is Netherlands now. Sorry, 1.5 degrees above average, 61 millimeters below average precipitation. Rotterdam, 1.4 degrees above average, 64.7 millimeters below average precipitation. This is now Denmark. Copenhagen, 0.5 degrees above average, 19 millimeters of precipitation below average. Aalborg, I'm hoping I'm pronouncing that right, 1.1 degrees above average, minus 22 millimeters below average precipitation. Now on to Germany. Now on to Germany. Berlin, 0.4 degree. Berlin is actually an outlier time, but it's kind of, I guess, it's in the flow of the North Sea. I won't explain. Let's just carry on. Sorry, I'm not there. No more interruptions. Berlin, 0.5 degrees below average, 31 millimeters below average precipitation. Hamburg, 1.5 degrees above average, 34.8 millimeters below average precipitation. Hanover, 0.5 degrees above average, 5.1 millimeters more precipitation than average. Cologne, 3.2 degrees above average, minus 72 millimeters of precipitation. I don't know, 72 millimeters of precipitation they don't usually get. Munich, 1.4 degrees. 1.4 degrees. 1.4 degrees above average. 30 millimeters below average. Leipzig, 0.6 degrees above average. 36.1 millimeters below average. Luxembourg, this is now Luxembourg. Luxembourg, 3.6 degrees above average, 70.4 millimeters of precipitation below average. Warsaw, 1.8 degrees above average, 42 millimeters of precipitation above average. Wrocław, 0.2 degrees above average, 38 millimeters of precipitation below average. Krakow, 1.3 degrees above average, 41.2 millimeters below average. Poznan, 0.7 degrees above average, 49.1 millimeters below average. Lublin, 0.7 Lublin, maybe that's Lublin. This is now minus, so 0.7 degrees below average, and 9 millimeters below average. Vilnius, so now this is Lithuania, 1.3 degrees above average and 28 millimeters above average. Riga, 0.9 degrees above average, and this is Latvia, Riga, Latvia, 0.9 degrees above average, 18.5 millimeters of precipitation above average. Estonia, Tallinn, 0.1 degree below average, 11 millimeters above average precipitation. Now this is on to Russia. Moscow, 0.1 degrees above average, 33 millimeters below average. St. Petersburg, 0.4 degrees above average, 40 millimeters of precipitation below average. Murmansk, 1.8 degrees above average, 26 millimeters of precipitation below average. Kaliningrad, 0.6 degrees above average, 21.4 millimeters of precipitation below average. Now on to Norway. Oslo, 0.9 degrees above average, 17 millimeters of precipitation below average. Stavanger, 1.2 degrees above average, 21 millimeters of precipitation below average. Bergen, 1.1 degrees above average, 28 millimeters of precipitation below average. Boda, 1.3 degrees above average, 24 millimeters of precipitation below average. Trondheim, just go down a bit. Trondheim, minus 0.7 degrees, 0.7 degrees below average, 39 millimeters of precipitation below average. Tromsø, minus 0.7 degrees on average, minus 0.7 degrees, 21 millimeters of precipitation below average. Stockholm, minus 0.5 degrees than average, 61 millimeters of precipitation below average. Gothenburg, now on to Sweden. Stockholm, I think we've just skipped Stockholm. Stockholm, minus 0.5 degrees below average, 61 millimeters below average. Gothenburg, 0.3 degrees above average, 20 millimeters below average precipitation. Huron, 0.5 degrees above average, 32.6 millimeters of precipitation below average. Helsinki, now on to Finland. 0.5 degrees above average, 22 millimeters of precipitation above average. Tampere, 0.5 degrees above average, 14 millimeters of precipitation above average. Rovaniemi, Rovaniemi. Sorry, I don't really know how to pronounce that. I'm so sorry, anybody in Finland, because I know that's horribly wrong. 0.1 degree below average, 81 millimeters of precipitation below average. Now on to Belarus, Minsk. 1.6 degrees above average. 34 millimeters below average precipitation. Brest, 2.3 degrees above average. 22.8 millimeters of precipitation below average. Kiev, now onto Ukraine, 0.4 degrees below average. 48 millimeters of rain below average. Lviv, 2.8 degrees. 2.8 degrees above average. 48 millimeters of precipitation below average. Lviv, 2.8 degrees above average. 15.2 millimeters of precipitation above average. Odessa, 1.8 degrees above average. 23.6 millimeters of precipitation above average. Kharkiv, 1.2 degrees above average. 20.5 millimeters of precipitation above average. Now on to Portugal. So I'll just scroll down a bit. Lisbon, 2.8 degrees above average. 3.8 millimeters below average precipitation. Porto, 2.4 degrees above average. 20 millimeters of precipitation below average. Madrid, now on to Spain, 2.5 degrees above average. 6 millimeters of rain below average. Malaga, that's also where they had bad wildfires in Madrid too. Malaga, 2.1 degrees above average. 0.1 millimeters below average precipitation. Seville, 1.4 degrees above average. Minus 0.6 millimeters below average. Valencia, that's also another place where they had bad wildfires. 2.7 degrees above average. 6.6 millimeters of precipitation below average. Barcelona, 3.1 degrees above average. 27 millimeters of precipitation below average. Zagarosa, that's also, I struggled with that before at the start of the video in part 1. Hopefully I got that better pronunciation. 3.4 degrees above average. 16.2 millimeters below average precipitation. Now we're on to, no, we've got one more in Spain. Palma, 2.4 degrees above average. Minus 6.1 millimeters below average precipitation. Now on to Switzerland. Zurich, 3.3 degrees above average. 102 millimeters below average precipitation. Bern, 4 degrees above average. 70.3 millimeters below average precipitation. Geneva, 72. Sorry, I just skipped the temperature. 4.5 degrees above average. 72 millimeters below average precipitation. Now on to Italy. Rome, 3.2 degrees above average. 8.1 millimeters below average precipitation. Milan, 2.8 degrees above average. 88.8 millimeters below average precipitation. Naples, 3.1 degrees above average. 18 millimeters of rain above average precipitation. Turin. Turin, 4.1 degrees above average. 45 millimeters of precipitation below average. Bari, 2.3 degrees above average. 19 millimeters below average precipitation. Palmore, 2.2 degrees above average. 4.3 millimeters above average precipitation. Bologna, 3.4 degrees above average. 26.2 millimeters below average. Calgia, sorry, I'm pretty sure I pronounced it completely wrong. Calgia, hopefully that's relatively right. 2.8 degrees above average. 3.8 millimeters below average. Athens, now on to Greece. 1.2 degrees above average. 4.1 millimeters below average. Thessaloniki, 1.8 degrees above average. 14 millimeters of precipitation above average. Corfu, 1.6 degrees above average. 29 millimeters of rain above average. 29 millimeters of precipitation, sorry. It could also be hail at this time, couldn't it? Tirana, now on to Albania. 3.7 degrees above average. 37 millimeters below average precipitation. Skopje, 0.5 degrees above average. 16 millimeters of precipitation below average, and that's North Macedonia. Pristina, 2.8 degrees above average, 25 millimeters below average precipitation, and that's Kosovo, obviously. Podgorica, I mean, that's slightly covered by 2.9 degrees above average, 14 millimeters of precipitation above average. That's Montenegro, obviously. Nicosia, 1 degree above average and 4 millimeters of precipitation below average. Cyprus. Sarajevo, 2 degrees above average, 66.1 millimeters below average. That's obviously precipitation. Bosnia-Herzegovina. Now on to Croatia. Zagreb, 2.2 degrees above average, 68 millimeters of precipitation below average. Split, 2.6 degrees above average, 34 millimeters of precipitation above average. Dubrovnik, 2.4 degrees above average, 33.1 millimeters of precipitation below average. Ljubljana, Slovenia, 1.3 degrees above average, 97.5 millimeters of precipitation below average. Vienna, now on to Austria, 1.8 degrees above average. Oh, I've just completely lost my place because I've zoomed down where we were. Vienna. Oh yeah, 1.8 degrees above average, 14 millimeters of precipitation below average. Innsbruck, 2.8 degrees above average, 33 millimeters of precipitation above average. Salzburg, 1.8 degrees above average, 122 millimeters of rain below average. Prague, now on to Czech Republic, 2.1 degrees above average, 5.4 millimeters of precipitation below average. Brno, 1.8 degrees above average, 71.5 millimeters below average. Bratislava, now on to Slovakia, 1.7 degrees above average, 4.7 millimeters below average precipitation. Poprad, 1.3 degrees above average, 6.8 millimeters below average precipitation. Now on to Hungary. Budapest, 1.4 degrees above average, 74 millimeters below average precipitation. Iga, 1.5 degrees above average, 58.4 millimeters below average precipitation. Baraga, 1.4 degrees above average, 56 millimeters precipitation below average. Now on to, that was fast. I mean, it took me maybe 10 times as long to actually make this Excel graph, an Excel table, sorry. Okay, now on to Serbia, Belgrade, 1.8 degrees above average, 27.2 millimeters of precipitation below average. Sombor, 1.9 degrees above average, 48 millimeters below average precipitation. Nice, 1.9 degrees above average, 21 millimeters below average precipitation. Sofia, now onto Bulgaria, 0.4 degrees below average, 17 millimeters of precipitation below average. Slivin, 0.3 degrees below average, 12 millimeters of precipitation below average. Bucharest, now onto Romania, 1.8 degrees above average, 37.2 millimeters of precipitation above average. That is an outlier because I believe Bucharest is just outside some mountain ranges and they've had some severe thunderstorms there in July, so that's more of an outlier to the actual region in general. Alexandria, in Romania, obviously, 2 degrees above average to 13.3 millimeters below average precipitation. Now on to Romania. It's a very sort of 1.5 degrees above average, 14.2 millimeters below average precipitation. Chisinau, now Moldova, 1.6 degrees above average, 35.3 millimeters below average precipitation. Trojan, 0.4 degrees above average, 4 millimeters of rain above average precipitation. That's Faroe Islands, by the way. And now on to Andorra. Andorra la Vella, 2.8 degrees above average, 28 millimeters of precipitation below average. Reykjavik, 1.1 degrees below average, 52 millimeters above average. And that's obviously because we've had such a massive a mega block and a heat dome in Central Europe, and the jet stream is going really far up north for a long period of time, and therefore it's just sticking over Iceland and dumping it with tons of precipitation. So that's you can definitely find a trend in this, but we'll be back in a second for the third smallest part. Trust me, it will be 5 minutes. It's just a little video of me, literally a 5-minute analyzation of Europe's weather in July. So part 3 is going to be a map, and I'm just going to analyze for 5 to 10 minutes Europe's weather, sort of general, sort of give you just a couple of sort of just my sort of what do you call it, opinion and analyzation of the month of July in Europe. So stay tuned for that. See you in part 3, or a very small, maybe it's a little small part, maybe it's, no, it doesn't matter. See you in part 3. Goodbye. Hello, welcome back everybody after the edit. I'm sorry about the quality of the map. I know it's not a very good map, but we're going to have to do for a last little bit of analysation. The reason why we've had so much dry and so much above average temperatures is because one of this mega system, which has been pretty much controlling, or basically it's been in such control for such a high percentage of the month, and this pattern is called the omega block. This pattern has been in charge of such a high percentage of the month, and it brings extreme extreme droughts, an extreme lack of moisture, and extreme heats. And so this shows you, this is why Iceland was so wet, that it's an up and around jet stream pattern, because high pressure pushes up into Central Europe from North Africa. Therefore, that pushes the jet stream out, because the high pressure is so expansive that it forces the jet stream to go outwards. But what happens is the omega block is different from a heat dome because it stays in place along the jet stream cannot flip back to its normal where it goes over Scotland, or its normal sort of route. If we just get this pen is over sort of Scotland, kind of comes why is this not working? It comes over here, and it comes over sort of Scotland, and then go back, and then sort of back around, and then back, and sort of back pattern back around like that. But when we have the mega block, the high pressure just keeps on staying there. Therefore, when we have this high pressure blockade for such a long time, it turns from a heat dome to a mega block, because the high pressure is there for such a huge amount of time that the jet stream is unable to flip back to its normal pattern through the north of Scotland and the south of Scotland, maybe northern England, and therefore there's a massive decrease in Atlantic low pressure systems that are able to break down the heat dome or the high pressure system. So therefore it just remains locked in place for huge amounts of time, Another massive mega block pattern we've had was in the hot summer of 1976, was it, or 1979? I'm sorry, it's one of those 2 years. But basically, this is what's kept. We saw in that massive European cities, 126 or 125 cities, we saw a lot of dry, and that's been the main pattern, and in my opinion, the main outlook for this. So July, at the end of the day, has been hotter and drier than average, and there's only been certain parts of Europe which have been wetter and cooler than average, and that's the sort of Baltic states and parts of Finland. This is where the jet streams come. It's the back and around pattern. So this is where it's been wetter and cooler than average. It's kind of been a split. Therefore, the Baltic states, Belarus, and parts of Poland and most of Ukraine have been cooler than average, and we saw that in the Excel sheet. They've been cooler and wetter than average, or at least not even. No, sometimes it's been so powerful they've not even been cooler than average. They've just been a lot. They've been still above average temperatures in these areas, just because this heat dome is so strong. But it hasn't been above average temperatures so extreme as we've had in the main high pressure area in Western to Central Europe. And so these areas have been a lot wetter and cooler not necessarily colder than average, but some areas have. We definitely saw that in the Excel chart, and that's sort of been the pattern. Western Europe's been hotter and drier, and Eastern Europe has been colder and wetter, or wetter but not, but still above average, but not as above average as Western Europe. And this midpoint here, Berlin, the Berlin was an outlier because we have sometimes these southerly flows through the North Sea, and that just allows cooler air to get down into northern Germany, and that's what the outlier Berlin was. But it has this sort of midpoint I'm representing here. It's all a bit of a mess. I realise this now. That is sort of near, basically on the edge of Warsaw. Berlin and Prague, that's been the mid, that's sort of been, that area has sort of been fluctuating constantly. But basically, there's been a massive split in July, and in July, West is hotter and drier than average, and I've already explained where it's just wet and cooler than average, we'll just say. And at the end of the day, this is going to carry on through August, but I think it's going to get weaker as we get towards the end of August, and then September it will probably carry on the same. I believe we'll see it at the outlook, but it looks like it'll be the same pattern, but it'll just be weaker and weaker until we get to October, where we'll probably have a very wet autumn, November, October, and December, early winter, because obviously the El Nino, that's a big trait from El Nino, because obviously you have in El Nino, you have a hotter, more extreme heat in the summer, more extreme heat we have more extreme heat in the summer, and more prolonged heat waves, and more drier droughts, and less precipitation. That has been the hallmark of this July and June. And then in autumn we get a wetter and so we get a wetter and milder late autumn and early winter. So we get a wetter and a milder. So it's a lot. This is when we seem to, but we'll probably have a lot more rain. So maybe we'll get close to our averages again, but we'll be probably flash flooding in some places. It could be quite extreme. But then. In late winter, we have colder spells, so drier than average, and then back up to summer. It's hotter than average. So April, spring might be hotter than average, plus May, and we saw that with the crazy heat wave in May. But I think El Nino has definitely turned summer a lot drier and hot, especially in Western Europe, and I think that's been the outlook of July. And I think this year will probably be drier than average, and it could be one of the hottest years on record. But I think we're all safe to say, with El Nino fully locked in by 2027, it's looking very, very likely huge. I've never seen such high percentage from scientists. Usually they're quite, what do you call it, conservative. 92%, I think I saw from scientists that said it is that 2027 is going to be the hottest year on record. So there is a lot of potential that, even though we've seen the really hot spells and really hot heat waves in June in Western Europe, and obviously now in Central and Eastern Europe, we could see even hotter. So that is kind of my outlook of this video, and I hope you enjoyed this video. I really hope you enjoyed. If you don't feel like subscribing straight away to my channel, because obviously this is the first video you've watched, we're not going to be forcing you. If you don't want to, you don't want to, and then you can come back and see another one, and if you like it, then you can subscribe. But please do follow and comment. I would like to hear your opinions and what you think of this. Thank you so much for watching the video, and please I've spent a long time making this video, 2 days, but thank you so much for watching this video. This has been Open Your Mind. Thank you so much. Goodbye! God, you look so